In this video, I will demonstrate how the multiplication system that we all learned as kids is programmed into this amazing structure of math and art. I will also demonstrate the structured existence of the geometric and dimensional shapes of whole numbers themselves, and I will also demonstrate the interconnectedness of all numerical base count systems expressed objectively through the visual forces of math art. To begin this expedition of the mathematical mind and all of its stunning and beautiful geometric structures, we will first look at counting in general. As children, we all learn to count from 0 in the linear progression using base 10. When learning to count, I remember having my first questions about infinity. How far does this line of numbers actually go? I also remember noticing that counting itself was a precise pattern with no divergence from the system. 8 was always in between 7 and 9, no matter how high or low or what direction you counted in. Later in life, I wondered what if this consistent pattern was demonstrating more than just repetition, but possibly some sort of shape to each number. Comparing a geometric line to counting and thinking of it as a one-dimensional system, it only seemed logical to view the multiplication chart as a two-dimensional plane of numbers. When examining a multiplication chart, in this case up to the 20s times table, I noticed that no matter how high your multiplication tables went, if reduced only to the ones digit, precise patterns with no divergence occurred, this time in the form of a two-dimensional array of numbers. Examining a solitary block of this infinitely repeating array of single digits, an amazing pattern begins to emerge by extracting each group of like digits individually. Drawing a straight line to each point from each point revealed the second-dimensional shapes of numbers. Examining the two-dimensional shapes of numbers, I began to notice some more patterns. First, how artistically beautiful the patterns all looked when superimposed on top of each other. Second, I noticed each digit had a geometric polar opposite. Third, that two-dimensional numbers have three classifications: odds consisting of 4 points, evens consisting of 12 points, and neutrals which don't fall into either previous category. The traditional view of odds and evens is taught to us on a one-dimensional scale, so we perceive an alternating pattern. Applying the same alternating pattern to the two-dimensional planes of numbers looks like this, except now the neutral numbers emerge. Looking at the two-dimensional polar opposites, I became very excited with the idea of producing three-dimensional shapes for each number. My first instinct was to add the polar opposites together, taking the polar opposite points and merging the two shapes by drawing a straight line from each point to all polar opposite points, such as in this example. Applying the same technique to all polar opposites, adding the two together and making the alternating connection, these new shapes emerged. Taking the newly forged odds and evens and adding the two together and making the alternation to these new shapes, two more shapes emerged. The resulting 7 symbols reminded me of a concept I have previously learned about called the chakras. This concept, however, was not taught to me as mathematics, but as a spiritual energy concept accessed by the balancing of polar opposite forces internally. This discovery of what appeared to be the mathematical representation of the chakras and ancient spiritual wisdom gave me great pause. Could the original expression of the chakras possibly have been some of the first math art? I spent many days contemplating these patterns. At a certain point, however, I realized that the patterns were still two-dimensional in nature, and that's when my mindset shifted to the third dimension. Taking the original 2D plane of numbers and placing the pattern onto 6 sides of a cube, One side looks like this, and the opposite side looks like this. Taking the two-dimensional number 1 and placing it on 6 sides of a cube, it would look like this. If you could see through the cube, it would look like this. If all the points of the number 1 were connected, it would look like this. This is the representation of the three-dimensional shape of the number 1. Repeating the steps of taking the two-dimensional shapes of numbers and applying them to a cube by connecting the center points of each like digit, I began to reveal all 10 digits 0 through 9 in 3D. Astonished by the realization of the 3D shapes of numbers' existence made my brain feel like it was about to explode. I was very amazed and confused at the same time. Did these shapes previously exist, or did I just make them up? As I continued drawing, I wondered, what did these shapes represent? Could I someday hold these shapes in my hands? Could my expressed ideas actually become 3D objects? These were by far the most precise and beautiful patterns ever generated by my hands, for certain. For me, these were my geometric masterpieces. Another geometric phenomenon that I noticed is that each color-coded point inside of the cube that the shapes were connected to, each individually created a tile that, when used in a tessellation pattern, created its own specific textured fabric-like pattern that can also be tessellated into infinity. Examining these patterns individually, I began to quickly realize that these tessellations created stunning detailed visual geometry, and that cycling through the patterns consecutively created some pretty amazing visualizations of this numerical system. These tessellations gave a clear example of the infinite nature of each number individually, as well as the working relationship between them all as a system. Just so we're clear up to this point, a one-dimensional system of numbers which are all points on a line, seemingly a very simple process of +1 counting that we all learned as kids by virtue of the one-dimensional system's existence, generates a two-dimensional system of numbers, which is actually something else that you learned as a kid as well, the multiplication chart. Making a simplified version of the multiplication chart by dropping all numbers except the ones digit on each point reveals a pattern in which you can now see the same chart in a way that you have never looked at it before. This newfound simplified perspective allows you to visually see the second dimensional shape of numbers by isolating each like digit individually, then connecting them all with straight lines from each point to each point. Now, taking that two-dimensional plane of numbers and putting it onto 6 sides of a cube, you would then be able to see a pattern revealed that allows you to visually see the third-dimensional shape of numbers. Comparing the first, second, and third dimensional progressions of a base 10 system, we get a simultaneous look at the digits from all three-dimensional perspectives for the first time. All of these shapes are following the same rules as the shapes in simple geometry: points, lines, planes, and cubes. Seeing these three systems together for the first time was astonishing for me. Why haven't I ever seen these forms before? With all the advancements the human race has made by applying the first and second dimensional shape of number systems to the physical world and everyday life, what could be possible if we understood and applied this third dimensional system to everyday life? Then I began to think it would only be logical to think that logical thinking itself takes place inside of these geometric spaces, right? There was also another thought that just kept getting louder. What about the fourth dimension? The tesseract hypercube is a four-dimensional cube and the face of hyperdimensional shapes. It can be described as a cube inside of a cube possessing toroidal motion in which it moves through itself in a type of infinite rotation. Taking another look at the three-dimensional shapes of numbers, I began to notice that just like the tesseract hypercube is a cube inside of a cube, that the 3D shapes of numbers also possess smaller replica shapes of itself inside of itself. It was obvious that these 3D shapes were fractal in nature, and, in my opinion, if given the same properties as the hypercube, could be set into four-dimensional motion. This visualization led to the thought that if there is such thing as a four-dimensional cube, a tesseract, a five-dimensional cube, a pentaract, a six-dimensional cube, a hexaract, and so on, then the same must be for these shapes. The realization soon set in that there was this infinite onion-like layered geometric structure that spanned all dimensions for every number, and that most of us have only seen or experienced a single two-dimensional side of this particular 9x9 dimensional layer that we most commonly use. My mind rapidly flooded with the idea that there was an interdimensional connectedness with each number throughout all dimensions spanning into infinity, and that I could express it using geometry. A simplified explanation of a base count is simply where the zero is placed in the count. Each base count then builds upon itself, repeating its measurement/frequency of digits. Example in one dimension, a base 6 versus a base 10 counted out to 30 shows the zeros occur at a higher frequency in the base 6 with the zeros highlighted. Now, in two dimensions comparing the same two base counts, we can see that there is a higher frequency of zeros in the base 6 covering 16% of the chart compared to base 10 in which 0 covers 9.87% of the chart. Now let's talk about the link between two-dimensional base counts and geometry itself. In this visualization, we will use these two squares and determine their size by measurement. In this case, we will use this small black square as our measuring tool. When measuring the two squares with our measuring device, we can determine based on our measurements that the left square is 2 black squares long and 2 black squares wide, and the right one is 3 by 3. These separate measurement/dimensional frequencies are representing all the same information, just on a different frequency. In this case, the information is that both the shapes are squares of different dimension/measurement, and the frequency of measurement is for the left square 2 by 2 and the right square 3 by 3. Now, in comparison to math, and more specifically the multiplication chart, we can see that these two systems have the same properties with added information. In the case of the multiplication chart, the measurement/dimension is the base count, and the information inside of the chart is its frequency. Each base count contains its own set of unique information, which is the frequency of numbers in the chart. As we progress through the dimensions of the base counts, we can see the frequencies become higher as they progress to base 10, where its two-dimensional frequency of digits is revealed. Now, looking at a base 27 multiplication chart in the same way as we did the base 10, we can see the same information represented on a higher dimensional plane at greater frequency. I chose to use base 27 because the English alphabet has 26 letters, plus the 0 that naturally occurs inside the system makes it a base 27. In reality, the system is infinite, but for this demonstration I will use base 27. As you can see, there are distinct 2D line shapes for all digits, and that like all previous dimension/base counts, each of these shapes has a polar opposite. When these base 27 digits are placed onto 6 sides of a cube, each digit creates its own unique tile that can also be tessellated into infinity. And when running through the progressions of these tiles, we see a very similar visual geometric progression on a higher dimension and frequency. After creating the 6-sided cube with each digit color-coded, I quickly realized that it would be almost impossible to connect these shapes using straight lines by hand. There's just too much information to contain on a paper. I knew that in the future I would need help rendering these shapes and their dimensions inside the vast digital space of a computer, but for now I will just use the color-coded tiles to continue explaining. Now I want to explain the connection of all numbers, both positive and negative, and the frequency in which they occur, and all base counts and their dimensional measurements. Looking at each base count 1 to 27 individually, we can identify the points for the number 1 in each separate numerical/dimensional plane. Each of these systems is in itself a complete number system. Any of these systems can be used to multiply accurately. Now, let's talk about the interdimensional connectedness of numbers, starting with the number 1. Visualizing each of the numerical/dimensional planes beginning to stack up on top of each other, the most shocking of all patterns emerged. This is what the positive number 1 looks like in all measurements and frequencies combined, base counts 1 to 27 in 2 dimensions. I repeated this process for each digit 0 through 26. I got the idea when I remembered how Benoit Mandelbrot simultaneously applied all of the Julia sets, creating the Mandelbrot set. In this visualization, it is important to remember that just as the one-dimensional system of numbers is imagined in both the positive and negative to extend into infinity, so too are these representations. In geometry, a dimension can only be perceived in between two polar opposite reference points for the respective dimensions. In the case of the cube, there are 2 opposing sides and 3 sets of polar opposites. After rendering all of the digits 0 through 26, I proceeded to repeat the process of adding polar opposites to the pattern. These patterns reminded myself, as well as many who I shared the images with, of Native American and other indigenous tribal textiles, baskets, and tribal art. Cycling through these patterns rendered an extraordinarily accurate rendition of the seemingly mechanical yet somehow natural workings of the interconnectedness of numbers inside of the first 27 layers of the mathematical bases of understanding. Seeing these 2-dimensional renditions of these patterns put onto 6 sides of a cube brings me to the patterns I shared with you in the beginning. These extraordinary patterns are a culmination of all of these systems converging into one system. I believe that all MathArt takes place inside of this infinite geometric cloud of encoded information. I someday hope to bring to Bridges MathArt 3D printed models of the 3D shapes of numbers, as well as much more accurate computer modeling of the interconnectedness of numbers. It is my personal belief that the study of these number systems as a single entity can lead to a higher understanding of numbers and math itself. Thank you infinitely for watching. I hope that posterity judges me on the fact that I am an artist and a dreamer, a free-thinking, imaginative consciousness, and not a crafted spirit or institutionalized student or scholar. These geometric representations are my attempt at expressing perceived reality.